All right, let's get into it. You know, when you think of Windows XP, your mind probably jumps straight to that green start button, maybe that famous grassy hill wallpaper. But what if I told you that hidden inside that 20-year-old software are the actual blueprints for the network you're using, well, right now? Seriously, this isn't just some nostalgia trip. We're about to do an archaeological dig into the very foundations of our connected world. And look, that's a fair question, right? In the tech world, 20 years is an eternity. XP is practically ancient. So why on earth are we talking about it? Why should you care about the networking tech and an operating system that's been unsupported for ages? Well, it's because the rules, the languages, the basic security ideas that were finally standardized and pushed out to millions of people in Windows XP, they're still running the show today. Understanding how this all got started isn't just for trivia night, it actually helps demystify this incredibly complex network we all depend on every single day. So if we really want to understand the tree, we have to start by looking at the roots. We're going to begin with the absolute basics. Why did people even start connecting their computers together back in the early 2000s? What was the point? You know, it really just came down to some very simple, practical problems. I mean, think about it. A good printer back then was seriously expensive. So instead of buying one for every single person, a network let an entire office share just one. And for the IT folks, being able to push out a critical security update to every machine all at once, instead of literally running around with a stack of CDs, that was an absolute game changer. It was all about making things more efficient and getting some control. And this really shows the two different worlds that XP had to serve, your house and your office. At home, you had what was called a work group. It was pretty simple, just a casual collection of computers where each one was its own boss. But in an office, oh no, you had a domain. And that was a much more structured, top-down setup, where a central server was the king, dictating all the user accounts and security rules. And you know what? That basic distinction is still at the heart of how we manage computers today. Okay, so you've plugged all the computers in. Now what? Well, they need to speak the same language, right? They need a set of rules so that a request from one computer can actually be understood by another. This is where we get into the nitty-gritty protocols that make the internet, well, the internet. Now, this might sound a little academic, but the OSI model was a truly brilliant idea. See, instead of having one massive, clunky program try to handle everything about networking, it breaks the whole process down into 7 distinct layers. Think of it like an assembly line. Each layer has just one specific job to do. This modular setup meant a company could invent, say, a brand new Wi-Fi technology at the bottom layer, without having to completely rewrite the software for how web browsers work at the top layer. It's the secret sauce that lets the internet constantly innovate without just falling apart. And here we have one of the most important trade-offs on the entire internet. Think of TCP like sending a registered package. It takes your file, chops it into little pieces, numbers every single one, sends them off, and then waits for a confirmation that every piece arrives safely and in the correct order. It's super reliable, which is exactly what you want for a web page or an important email. UDP, on the other hand, is like sending a postcard. You just write your message, pop it in the mail, and hope it gets there. It's way, way faster, which makes it perfect for a video call or online gaming, where speed is everything and a few dropped pixels here and there don't really matter. Let me put it this way. Without DNS, the web as we know it would be completely unusable. You wouldn't be typing in website names. Nope. You'd have to memorize a long string of numbers, like 142.250.191.78 for every single site you wanted to visit. DNS is that silent, heroic translator working behind the scenes, turning the names we can remember into the numbers computers actually need. It really is the internet's phone book. Okay, so all these rules and languages were suddenly put on steroids by a massive, revolutionary shift. The Windows XP era is defined by that moment, when we all moved away from that awful screeching sound of a dial-up modem to the always-on world of broadband. I mean, just look at that difference. That's not just a small bump up, that's a complete transformation. Going from a maximum speed of 56 kilobits per second to 1,500 or even more, that changed what the internet was. It went from being a place where you'd wait patiently for a single picture to load to a place where you could stream music and even video. This explosion in speed unlocked the modern internet, and Windows XP was the operating system that managed that whole transition for millions and millions of people. And for the first time, you actually had choices, but each one came with its own catch. DSL was pretty clever. It used the phone lines you already had, But the catch was the farther you lived from the phone company's central office, the slower your connection got. Cable was usually faster, but you had to share the connection with your whole neighborhood, which meant everything could grind to a halt when everyone got home from work. And satellite? Well, it could reach anywhere, but the massive distance the signal had to travel created a noticeable delay, or latency, that made things like online gaming pretty much impossible. So this always-on internet was incredible, but it also created a brand new and very big problem. Your computer was no longer just visiting the internet for a few minutes at a time. It was now a permanent, visible target 24/7. This forced a huge shift in thinking, and Windows XP was right there on the front lines, introducing basic cybersecurity ideas to the average person for the very first time. Before Windows XP, if you wanted a firewall, you had to go find one and install it yourself. But with Service Pack 2, Microsoft flipped the switch and turned one on by default for everybody. The Internet Connection Firewall, or ICF, was a total game changer. It basically acted like a bouncer at a nightclub, standing at the front door of your internet connection. If it didn't recognize the incoming traffic, if it looked like an uninvited guest, denied. Simple as that, but absolutely revolutionary for its time. So what was this digital bouncer's job description? Well, its main job was to enforce one simple rule: don't talk to strangers. It blocked any traffic that you didn't start. So when you went to a website, it knew to let the information from that website back in. But a random probe from some server across the world? Blocked. And, crucially, it started blocking inherently risky things like Windows file sharing from being exposed to the whole internet by default, which closed a gigantic security hole. Now, along with that firewall came another really clever security trick that your home router still uses to this day. It's called Network Address Translation, or NAT. The idea is brilliant. Inside your house, your laptop, your phone, they all get their own private, local address. But to the outside world, they all hide behind the one single public address of your router. Your router acts like a company receptionist, taking all the incoming data and making sure it gets to the right device. For an attacker, it makes it incredibly difficult to single out and target your specific laptop. It's like hiding in a crowd. So we've seen how XP laid out the basics of networking, how it handled that huge leap to broadband, and how it introduced cybersecurity to the masses. Now, let's pull it all together and look at exactly which pieces of this 20-year-old puzzle are still holding up our digital world today. I mean, after all this time, with all the incredible changes and breakthroughs we've had, you'd probably think not much is left, right? Well, you'd be surprised just how many of these core ideas aren't just still around, but are absolutely essential. The basic language of the internet, TCP/IP, is still the same. DNS, the internet's phone book, is more important than ever. The fundamental idea of a firewall blocking uninvited traffic is a non-negotiable part of modern security. Those detailed file permissions from NTFS, they're the direct ancestor of the security controls we use in Windows 11. Even the concept of remotely controlling another computer, which XP made popular with Remote Desktop, is now the backbone of IT support and our entire remote work culture. And really, that's the main takeaway here. The next time you're setting up your Wi-Fi or trying to figure out why a website isn't loading, or just thinking about your online privacy, you're interacting with systems built on these very ideas. Knowing where they came from, it doesn't just give you some cool historical facts. It gives you a much deeper understanding of the tech you use literally every single day. And that leaves us with a really fascinating question to think about. We look back at things like dial-up and built-in firewalls and see them as these obvious, foundational steps. So what's happening right now with cloud computing, with AI, with mobile networks that's laying the groundwork for the next 20 years? What will future tech folks look back on and see as the quaint but essential building blocks of their time? You see, looking back at XP doesn't just explain our present, it gives us a new way to think about the future.